Welcome to Physics World Online College, where we simplify the concept of physics for you to understand and also to excel in your exams. In our class of today, we shall be looking at capacitor and capacitance. Here we want to know what is a capacitor and what do we mean by a dielectric material. Likewise, how we can define and also calculate the capacitance of a capacitor. Let's take the first part, which is what is a capacitor. We say that a capacitor is an electric device that stores electric charges or electricity. We can also say that it is a two-terminal electric component that has the ability to store electric energy in the form of electric charges. Let's take that. A capacitor is an electrical device which stores electric charges or electricity. Say it is a two-terminal electric component which has the ability or capacity to store electrical energy in the form of electric charges. Now, the capacitor can be represented using two conductors separated by an insulator. That insulator we will call the dielectric. Now, the conductors, also called the metallic plates, are made up of equal but opposite charges. So they are made up of equal but opposite charges. So I'm calling this plate A. It's metallic plate A, made up of positive charges, and I call this plate B, metallic plate also made up of negative charges. Now we have equal number of what? Positive and negative charges. What does that mean? It means that the net charge on the capacitor is 0. It means that the net charge on the capacitor is what? Is 0. Now, if we have these two plates, I said the insulator between the plates, we call it the dielectric material or the dielectric substance. Now, the purpose of the dielectric material is to increase the capacitance of the capacitor. That is a popular question. Just say, what is the purpose of the dielectric in a capacitor? It is to increase the capacitance of the capacitor. Now, I have given you a simple sketch of the capacitor connected across what? A voltage. These are the parallel plates, the two metallic plates. the two conductors of the capacitor. Here you have the insulator, which we call the dielectric material, like I said, whose function is to increase the capacitance of the capacitor. Now, the distance or separation between the two conductors or metallic plates, we will call it D. So, I said, since we have equal but opposite charges on the plates of the capacitor, then the net charge on the capacitor is what? Is 0. Now, I also want you to note that the symbol we use to represent the capacitor in an electric circuit is this, where the two stroke represent the two terminals, and of course they are of equal what? Length. If you check this symbol is for a cell, and the terminals are not of equal length, but this one for the capacitor is what? Of equal length. So anytime you see that in a diagram, circuit diagram, you know that represent the what? The capacitor. Now, when you connect the capacitor across a battery, then the capacitor will be charged by the battery. The battery will transfer charges onto the what? The capacitor. Now, I said the dielectric material is an insulating material, or an insulating medium, or an insulator placed between the conductors, the two metallic conductors of the capacitor, whose function is to increase the capacitance of the capacitor. Let's take that. A dielectric material is an insulator or insulating material, or an insulator placed between the plates of a capacitor. Its purpose is to increase the capacitance of the capacitor. Now, if these two conductors are plane, we will call this capacitor parallel plate capacitor. Likewise, if these two conductors are spherical, we will call the capacitor spherical capacitor. And also, if these two plates are cylindrical, we will call the capacitor cylindrical capacitor. So, this classification of capacitor I have mentioned are based on the plates. Later, we will talk about the types of capacitor based on the nature of material of the dielectric, that is the dielectric material. That one will give us another what? Set of names for the capacitor. So what have I said? I said we have parallel plates capacitor. That is when the conductors are what? Plane conductors. Spherical capacitors, when the conductors are what? Spherical. And cylindrical capacitors if the what metallic conductors are what spherical in shape. Mind you, I said we will talk about naming the capacitor depending on the type of dielectric material that will be in the next class. Now, let's talk about the capacitance of a capacitor. We say the capacitance of the capacitor is the ratio of the charge on the capacitor to the potential difference or voltage of the capacitor. Let's take that. Capacitance of a capacitor, we use letter C to represent it, is defined as the ratio of charge on the capacitor to the potential difference of the capacitor. Now, we can also define it as capacitance is the ability of a capacitor to store electric charges per unit of voltage across its plate. Now, if we translate this definition into mathematics, then we will have something like this. We say mathematically, capacitance, of course, of capacitors equal the charge on the capacitor divided by the voltage or potential difference. Which means C, representing the capacitance of the capacitor, is equal to Q, representing the charge on the capacitor, divided by V, representing the what? The voltage or potential difference of the capacitor. So that is the formula that we will use to find the capacitance of the capacitor if the charge and the potential difference across the capacitor are unknown. Remember, once a mathematical formula is given to you, you can be asked to look for any of the quantities represented there. So, in the example before us, I will solve for the capacitance, but in the classwork we have, which you will do after the class and submit to me, we are asked to look for the charge in one of the questions. So that is just to tell you that once a formula has been given, any part of it can be asked if the other quantities are known. So let's answer the example. The solution to the example, we are given that a capacitor is charged to a potential difference of 1000 volts. So V, the voltage or potential difference across the plates of the capacitor, is given as 1000 volts. Then we are given that the charge on the capacitor is 8 times 10 raised to the power of minus 3 coulomb. Q is given as 8 times 10 raised to the power of minus what? 3 coulomb. Now, this 8 times 10 raised to the power of minus 3 coulomb could have been given as what? 8 millicoulomb. 8 millicoulomb. So to remove the milli, you will multiply by 10 raised to the power of minus 3. So take note of this second classwork here, where you are given 5 picocoulomb, which means you will multiply by the equivalent value of pico. I leave that for you to determine. Here is what? 25 kilovolts. Likewise, know the equivalent of what? Kilo, and substitute to obtain what we are asked to look for there. Now, the question says, find the capacitance of the capacitor C. So we are looking for the capacitance of the capacitor. So we quote the formula that we have. We say from the formula, capacitance is charge divided by what? Voltage. We do our substitution. The charge is 8 times 10 raised to the power of minus 3 divided by the voltage is what? 1000. And 1000 also means 10 raised to the power of what? 3. So we have this as 8 times 10 raised to the power of minus 3 over 10 raised to the power of what? 3. This 10 raised to the power of 3 will go top to give us 10 raised to the power of minus 3. So we have 8 times 10 raised to the power of minus 3 and also times 10 raised to the power of what? Minus 3. Or I can write it this way. 10 raised to the power of minus 3 minus, this minus because of the division, then 3, the power of this 10. So that will give me capacitance C is equal to 8 times 10 raised to the power of minus 6. 10 raised to the power of minus 6 is a value for a particular submultiple unit. I will say that shortly. Now, the SI unit of capacitance is farad. Farad, short form of Faraday. That is the SI unit of what? Capacitance. Now, because the 1 farad is very large, most times we use a smaller version, smaller unit for the farad. So we can use micro, we can use pico, we can use what? Milli, as I used earlier here to represent the unit for capacitor. Now, this 10 raised to the power of minus 6, I can write it as 8 microfarad. So this symbol is the symbol for micro. And likewise, in future question where microfarad is given, to remove this micro sign, you multiply by 10 raised to the power of minus 6. Good. So I want to make a point here as well. From this formula, we see that if we take the unit of charge as coulomb, and we take the unit of potential difference of voltage as volt, then we can obtain a derived unit for what? Capacitance, which in this case will be what? Coulomb per volt. So we say 1 coulomb per volt is 1 farad. 1 coulomb per volt is what? 1 farad. So you can be asked, which of these is or unit of capacitance? Yes, farad is the SI unit of capacitance. In the absence of farad, coulomb per volt is also acceptable. So both are unit of what? Of capacitance, but the SI unit is what? Is farad, like I've said before. So please do this classwork and submit to me. I will reply you later. See you in the next class. Bye.